So in this video we're going over the AQA GCSE additional physics topic of acceleration. And essentially, acceleration applies to an object which has a resultant force which doesn't equal zero, so a non-zero resultant force, which we discussed in the last video. And if it has this, it will begin to accelerate, and this applies to whether it is moving from a stationary position, so it will get faster and faster from not moving to moving at a particular speed, whether it is getting faster, or whether it's changing direction, because even when it's changing direction, it will start to accelerate as it goes into the new direction of the resultant force. So the extent to which an object accelerates is affected by two things, mass and force. So first we're going to talk about the effect of force. And when thinking about it, you need to realize that the object accelerates in the direction of the resultant force. So, for example, if a ball was rolling down a hill, it would accelerate in the direction of gravity because that would be the main direction of the resultant force. And the size of the force also affects the acceleration. So if the force being applied on the object is larger, the acceleration will be greater, and this makes sense. So imagine trying to pull a box using two strings along a road, and then imagine attaching the same box to a car and that pulling it. And that's two very different forces. You can pull the box at a much lower force than the car can pull the box. And so I've drawn two diagrams to help you understand this. You can see the man here is pulling a box at a small force, while you get a car pulling the same box and it accelerates at a much higher rate and is moving much faster. So this is how we get to the start of our equation, because doubling the force doubles the acceleration. The two are directly proportional. Next we need to talk about the effect of mass. So a force acting on a larger mass will have less of an effect than a force acting on a smaller mass in terms of acceleration. So larger masses tend to accelerate slower when compared to smaller masses. So imagine trying to push a large metal crate along a road compared to the small cardboard box we were talking about earlier. It would move a lot more slowly and it wouldn't accelerate very fast. Whereas if you're pushing a small cardboard box, the acceleration would be much greater. So this gives us the part of the equation, because we know that doubling the mass halves the acceleration. So finally we get to the equation for acceleration that you will have in your physics data booklet in the exam. And when looking at equations, it's always good to think about the different units. So force is being measured in newtons, mass is being measured in kilograms, and acceleration is being measured in meters per second squared. And force equals mass times acceleration, but if we're going to be asked to work out the acceleration, we're going to need to do some rearranging. So it's better to actually learn the maths triangle for this example. So a better way to look at it is to have force on the top of your triangle and mass and acceleration at the bottom. So if we were trying to work out mass, we just need to have force and divide it by acceleration. If we were trying to work out acceleration, we just need to take our force and divide it by the mass. And finally, I've got an example of a question you could be asked in the exam. So we would be asked, what is the acceleration of a 10,000 gram metal ball being pushed with a resultant force of 50 newtons? And here we need to go back to our maths triangle. So what are we trying to work out? Well, we're trying to work out acceleration. So acceleration equals force divided by mass. So A equals F over mass, and we then need to look at the units to make sure they match up, because you can always be tripped over here. And getting the correct units is actually part of the 3 marks. So our acceleration, we know we need to give our final answer in meters per second squared. Our force needs to be in newtons, it is, and our mass needs to be in kilograms, but we're given it in grams, so we need to do a quick conversion. And the conversion is quite easy, you just need to divide by 1,000. So 10,000 divided by 1,000 equals 10 kg. So that's our mass, and we know our force is 50, so A equals 50 divided by 10, which equals 5 meters per second squared. And that's your answer. I hope this video was helpful. Thank you.